Hello guys, this is Cryness here, and today we're taking a look at inventories, containers and screens in Minecraft Forge 1.16.5. First we want to create a new package and call that storage. In that we want to have another package, we want to call this example storage. In this package we will create 4 different classes, one for our block, one for the tile entity, one for the container, and last but not least, one for our screen. So we want to go new class, and we want to call this class example storage block. Then we want to create another Java class and we want to call this example storage container. The third class will be named example storage screen. For the last one we want to create a new Java class and we're gonna name it example storage TE. TE stands for TileEntity here. Let's start off in our example storage block class. This class should extend block, so we want to go extends block. Make sure to select the correct one. Now we can automatically create the constructor for this class. Remove the properties from the arguments and instead in the super supply abstract block.properties.off. For this we're just gonna go material.metal. After that we need to implement 2 methods. Those 2 methods are hasTileEntity and getTileEntity. So let's start with hasTileEntity. We want to return true because it will always have a tile entity. Then we will create our createTileEntity. And before we can return our tile entity, we need to actually make it. So let's go to our example storage tile entity. This one will extend tile entity. And again, we want to create constructor matching super. And again, here we want to remove the tile entity type from our constructor. So now we need to create a new tile entity type for our tile entity that we just created. That means we will need a new init, so we want to go new Java class, call it TileEntity init. In here we will have a public static final, deferred register of type TileEntity type and wildcard. We're gonna call this TileEntity types. This will be equal to a deferred register.create forge registries.tileentities and of course supply your mod ID in the end. Now we want to construct the registry object, so public static final registry object of TileEntity type, and here we want to have our tile entity, so we will go example storage TileEntity. The name of this will be storage underscore TE, and this will be equal to TileEntity types.register. Supply the name, that will just be storage in my case. And now we want to go lambda into TileEntity type dot builder dot off. Now we need our supplier. This supplier will be the constructor of our tile entity, so we will go example storage TE new. And now we also need to register our block to make it valid for our tile entity. So we go public static final registry object of storage block inside our block init. This will be called example storage and this will be equal to blocks.register. We can name it the exact same way, so again just call it storage. and this will be supplied by an example storage block new. After that, let's go back into our TileEntity init, and here we wanna supply block init.examplestorage.get. After that, we wanna build, so .build with the data fixer type of null. After that is done, we can go back in our example storage TileEntity and supply the TileEntity type we just made. So we're gonna go TileEntity init.storage.te.get, and we have a valid TileEntity for our block that we just created. After that, we wanna go back in our example storage block, and in create TileEntity we want to return TileEntity init.storage.te.get.create. And that is our block mostly done. Now let's get back to our example storage TileEntity. In here we want to create a method that will give us our inventory. Our inventory will be an item stack handler, and this implements iTemHandler modifiable, and that is the one we will need. So we will go public iTemHandler modifiable, create inventory, and we want to return a new item stack handler of your preferred size, how many inventory slots your inventory is gonna have. For my tutorial I will go with 12, but that is absolutely up to you. Now here we can go curly braces and override a method directly in this instance. So we want to override is item valid. We will change this later on, but for now we will check if our slot is indexed 8 or below. So we want to go if slot less than 9. We want to return stack dot get item is equal to items dot golden apple. What does this mean? If we have an inventory, there are certain items that can be valid for a slot. In here you can set your inventory up to only accept, for example, sticks. Accept only saplings if you have a tree planter, something like that. Or you can just make it accept only golden apples. For the last 3 slots of our inventory, we will just return false. That means that hoppers cannot place items inside this inventory slot when we set it up correctly. After this, we want to create a private final lazy optional of iTemHandler modifiable, and we want to call that inventory. This will be a lazy optional .off this create inventory. Now it tells us a warning that our create inventory function is not annotated with add non-null, and we can just fix this by adding a add non-null above our function. But this inventory isn't any good if we can't get it somehow. So we want to create a method for that, and we want to call it public iTemHandler modifiable get inventory. We want to get the value out of the lazy optional. So we need to return a inventory dot or else throw. Now we need a supplier, so we will go lambda into a new illegal state exception, and the output we want for here is inventory not initialized correctly. This will make it so that if something happens to our inventory that is not intended, so we can't get it out of the lazy optional, it will throw an exception. This will probably never happen to you. It never happened to me. It is just best practice to always throw an error if there's a value that is absolutely not expected and will ruin or break stuff inside your game. Now let's get to saving and loading the values inside that inventory. We want to override the save and load function of the TileEntity. First you want to rename the method parameter to compound NBT. In here we will just remove the return and we will have super.save of compound NBT, and we want to put our inventory in there. So we will go compound nbt.put. The key for this will be a string of inventory. The inbt that is supplied will be the inventory, so get inventory, cast to an item stack handler. Then after the super.load, we will again cast our get inventory to an item stack handler. Don't forget the brackets. And we will deserialize the compound NBT. In here I made a mistake that we will fix at the end of the video, because in the state that it is right now, it will not save. If you want to fix the error now, I have a timestamp in the description where you can jump directly to the fix at the end. For now, we will just add one last function call to our load method, and this will be this.setChanged. This will make sure that our tile is never skipped when saving the world. Now let's jump into making our container. We will go into our example storage container. This class should extend container, so we will go extends container. You want to automatically implement the required methods, and we will also create a constructor matching the super. Then we will fix the constructor parameters. We will rename the int to id and remove the container type entirely. In our super, we also want to rename the second one to id. And for the first one, we will create our own container type. We will add some more method parameters that we will need for our container. Namely, we will add an iTemHandler modifiable, player inventory. We will add another iTemHandler modifiable that will be our storage inventory. We will add a player entity, player, and we will add a blog post pos, and that will be everything done for our constructor. Then we will create our container type. So in inits, we want to create a new Java class, and we will call it container type init. In this container type init, we will have a public static final deferred register of container type of wildcard. This will be called container types, and it will be equal to deferred register.create for registries.containers, and again supply your mod ID. Then we will have our registry object, so public static final registry object, and now we want to have a container type of our example storage container. And that will be example storage container. That will be equal to container types dot register. We will call it again storage. And this will be lambda into iForge container type dot create. And here it wants a factory from us that we will now create. So we will go back in our example storage container and we will create a method. This method will be public static and it will return an example storage container. This method will be called getClientContainer. The method parameters for this method will be an int, that will be the ID, an player inventory, that will be just the player inventory, a packet buffer, that will be called buffer. And we want to return a new example storage container with the ID, new inventory wrapper of player inventory, then we want to initialize a dummy inventory, so we will go new item stack handler of size 12. Then we will supply our block pos, that will be blockpos.0. And finally, we will have our player inventory.player. Actually, we need to permute those arguments, and IntelliJ already provides a method to do so. Now, let's head back into the container type init. And inside the iForge container type.create, we will have example storage container get client container. And this is everything we will need in the container type init. Now in the container, we will go container type init dot example storage container dot get in our constructor inside the super. Then we will create a variable for an iWorldPos callable that will be a private final iWorldPos callable, and we will name this WorldPos callable. Now we will go back inside of our constructor and we will go WorldPos callable is equal to iWorldPos callable dot create player dot level and the pos that we just supplied. Now let's fix up the still valid method, and the only thing we need to do is to return still valid of WorldPos callable, rename the method parameter to player, supply the player and also the block that this WorldPos callable is attached to. This will be our block init.example_storage.get. Now that we have a getClientContainer method, we will also need to get the server container. So we will have another method that will be public static iContainerProvider, and this method will be called getServerContainerProvider. The method parameters for this method will be example storage te and a block pos activation pos. And we want to return brackets ID player inventory and the server player and we will go lambda into a new example storage container of ID. For the player inventory, we will have a new inventory wrapper of player inventory, the te.getInventory. Then we will have the activation pos and also the server player. And again, I transmuted them wrongly. You can fix that very easily. Now we have our two methods to create a container, client and server side. Great. For the next part of this video, we will return in our TileEntity. In there, we want to override the getCapability method. In there, we want to check the sides. So in this case, we will check if the side is either north, west, south, or east. We can do this with a simple if check if direction.plane.horizontal.test, put in the side, and inside the if we wanna return inventory.cast. Then we wanna have an else and add another requirement to our if. So we wanna go add cap is equal to capability item handler dot item handler capability, and else we want to return the super.capability with cap and side. Next, we will actually set up the slots for our container in our example storage container. So we will head over there, and inside the constructor of example storage container, we want to go for int I equals 0, I smaller than 3 plus plus I. Inside that for loop, we want for int j equals 0, j smaller than 9 plus plus j. And inside this loop, we will go this.addSlot new slot item handler of player inventory. For the index, we want to have j plus I times 9 plus 9. And for the x and y values, we want to have 8 plus j times 18. And for the y position, we want to have 84 plus I times 18. This will add the player inventory to our screen. Then we also need to construct the player hotbar. So we want to go for int k equals 0, k smaller than 9 plus plus k. And inside that for loop, we want to have this.addSlot new slot item handler of player inventory. The index is k. The x position is 8 plus k times 18, and the y position is 142. And the y position is 142. Now for our actual container slots, we will have a for loop with int I equals 0, I smaller than 9 plus plus I, and we want to again have this.addSlot, and we now want to create a new slot for ourselves that is a bit special. So we are going to make a public static class bone meal slot. extends slot item handler, and inside that we just want to create constructor matching super. Then we will override the may_place method, and we will return stack.getItem is equal to items.bonemeal. If you want to have this be like a golden apple slot, then you can also do stacks.getItem is equal to items.goldapple, whatever you want. Then in the add slot, we want to have a new bone meal slot of the storage inventory. The index of that will be I. The x position will be 9 plus, now in brackets, I divided by 3 times 18. And for the y position, we want to have 18 plus in brackets I modulo 3 times 18. Modulo is just the percentage sign. Then we want to create the for loop for our last 3 slots. We will have a for loop of int k equals 0, k smaller than 3 plus plus k, and it will be inside this for loop this.addSlot, new slot item handler of storage inventory, k plus 9, the x position will be 151, and the y position will be 18 plus k times 18. Now these slots are made, but we still need to override one function, and that function is called quick move stack. If you don't override this, your game will crash if you try to shift click any item inside your inventory. Your inventory. So first thing, we will rename the int to index and the player entity to player. And if the index is greater or equal to 36, we want to move item stack to this.getItems.get at index. We want to have it from 0 to 35. So the first argument will be 0, then 35, and in the end we will have a false. Else we will also have a move item stack to, but instead of 0 and 35, our boundaries are 36 to 48. And again, we will have a false in the end. The false in the end is just that it goes in the forward direction of the index and not the backwards direction. And in the end, we just need to return item stack.empty. Now our container is finished, so we will move over to create the screen for our container. So we want to start in example storage screen. This one should extend the container screen, so we will go extends container screen of example storage container. Now we want to implement the required method and also create a constructor matching the super. In this constructor, we will set the image width to 175 and the image height we want to set to 183. We will start with an if check, so we will go if this.Minecraft is equal to null, we want to return. Then we will have the render system.color for f, and we wanna supply all ones for the arguments. This will be the red, blue, green, and alpha value of the texture that we supply, and we want it to be exactly as it is inside our texture, so we will need to go 1 for all of those arguments. Then in the next step we will bind our texture so that Minecraft knows that this is the texture that it should now be drawing. So we will do this.Minecraft.get texture manager.bind. We will have a private static final background texture that will be just a resource location. And this will be equal to a new resource location of example mod.modID, and the path will be textures/GUI/example.png. We will put that there later. For now, we want to supply the resource location to the .bind. So inside the .bind we will have the background texture. After this we also need to know where to start drawing the texture from. So we will have int start x is equal to this.width minus this.image_width, and we divide that by 2 so it is centered. Then we have the start of y. This will be equal to this.height minus this.image_height, and we also want to divide that by 2. After we have done this, we can call this.blit, and we want to supply the stack, the start x, start y, 0, 0, this.image_width, and this.image_height. The next thing will be to override the render method. We want to rename the parameters again. The matrix stack should be called stack. The first int will be the mouse x, the second int will be the mouse y, and the float will be partial ticks. We will have super.render stack mouse x, mouse y, and partial ticks. Before we call that, we actually need to call super.render background, and this should take in the stack. And the last step will be to call this.render tooltip of stack, mouse x, and mouse y. Now let's head into our main mod class, and inside the main mod constructor we want to register the TileEntity types and also the container types. So we will have TileEntity init.TileEntityTypes.register in the mod event bus, and container type init.containertypes.register the mod event bus. Then we want to go into a client setup that has the FML client setup event. In there we want to call screenManager.register container type init.example storage container.get, and for the screen factory we will just have an example storage screen new. So we tell the game to use this screen for said container. The last step will be to actually tell the game to open our container. So we need to go into our block class and override the use method. So when the block is clicked, we actually open up the container. We want to rename the parameters to block state state, world world, block pos pos, player inventory player, hand hand, and block ray trace result will just be called hit. Then we want to get the block entity, TileEntity. Block entity is the new name. So we want TileEntity tile is equal to world.getBlockEntity of position, or just pos. Then we want to have an if check, if tile instance of example storage TE and player instance of server player entity. We want to have the example storage TE. TE is equal to tile, and it will tell you to cast that to an example storage TileEntity. We already made sure that our tile is an instance of this class. Next, we want to define an iContainer provider that will be equal to example storage container.getServerContainer of the TE and pos. Next, we will have an named container provider named provider, and that will be equal to a new simple named container provider. And this will be made by our provider and an iText component that will be the title that it shows inside the screen. So let's make a title for this. I recommend going inside the example storage container and creating a public static final translation text component. That will be the title. And it will be equal to new translation text component of container.example storage. This title will now be supplied to our named provider. So we will have example storage container.title. Then we want to open the UI. So we will go network hooks.open UI of the player. It will tell you to cast it to a server player entity, which we also checked before. It will have the named provider, and that is all we need to open the screen. Then we also want to tell the game that the player is currently inside a screen. So we will award the player with a special stat for that. We will go player.awardStat, stats.interact with Cryness, because the Cryness interaction is basically the same as interacting with any other inventory in the game that the player inventory is involved. So once we added this, we can return action result type dot success. Now let's also put in the texture at the right place. This will be in assets, example mod, textures, UI, and the file name will be example.png. I already made this texture beforehand, and you can find a download link to it inside the description. Now here is the error that I alluded to in the first minutes of this video. In the load function of the TileEntity, we will need to deserialize the NBT by doing compound nbt.get inventory, and we need to cast that to a compound NBT. Without further ado, let's see how it looks in game. Now let's place down our block. This will be example mod storage. And you can see that we can place items inside the slots. Only bone meal is valid for the left ones, and in the right ones we can basically put anything we like. Also, it saves the items now correctly and loads them on startup. Thank you all for watching. If you enjoyed this video, please hit the like button, subscribe to my channel. There will be more videos like this coming out very soon. Have a nice day.